Wait, it does end up going at the same time, more or less the same time in the end.
See, that's the problem with this apparatus. Sometimes, most of the time, it doesn't quite launch. That's pretty good, right? Tie! Right? You saw it, they tie. All right, try again. Must have been a fluke. Stop it, Ian. All right. When in doubt, blame Ian. Tie. Okay, so I think at this point you might have noticed something. Can anyone explain what you noticed? It's not a tie. Who wins? Low road. So why did you all say tie? It wasn't silly. You were thinking about something, just the wrong thing. What were you thinking of? Yeah? Yeah, and you were using the idea of conservation of energy to say, look, if it goes down, sure, it's going to speed up, but then when it comes back the same height, delta H is 0, so delta V squared should be 0, same speed. However, the winner of the race is not determined by the speed, it is by the time. So now I need somebody to explain to me why it now makes sense to them that the low road will take less time. This is subtle. Okay, anybody brave enough? Somebody have a good explanation? Ah, yes, way in the back.
The low road goes faster for that section of, I guess, road in the middle.
Yeah.
So while the high road is going at a steady pace, it will speed up, go faster, then slow back down to the same pace as the high road, but it will be in front.
So she says that because the low road travels this distance at higher speed, and the high road is just allegedly, at about approximately constant speed, therefore it's going to take less time for the low road. Who has to go farther? Wait a second. So, okay, it's farther and faster. Who wins? Its path is longer, but its net displacement is the same, and that doesn't really help me. Anyone have an airtight argument? It's true, the ball that takes the low road starts going faster, and it's going faster all the way along until it gets up again, and then it's at the same speed as the high road, but it also had to go farther. Yeah, Lakshay.
You don't care about how far it goes, along the x, right? So,
Okay.
if it was the same, x distance that, it would go, and then it'll,
Yeah, it definitely goes the same x distance. But its speed now has to be divided between x and y, right? So how do I know who wins?
well, that means you gotta check if the horizontal velocity is greater than what it was.
Booyah. Say it loud, man.
You gotta check if the horizontal component of velocity when your ball is falling down is greater than the velocity was at the flat portion.
That's awesome. Okay, so what he says is you have to check about the horizontal component of velocity. So now we're almost done. What's the argument that says that the horizontal component of velocity has to be at least as big and typically bigger in that stretch than for the high road? So here comes this ball, and now it's on this part of the ramp. What forces are on it? Gravity, that's it, right? Which way is the normal force? Yeah. So she says, ugh. Okay, so why? Can we get that on camera? Yeah. So why does that Why does that help? Oh, Lydia's now gesticulating wildly. All right, so Lydia, why does that help?
Because if we, unlike force diagrams we're doing, keep the x direction horizontal, then we split up the normal force into vertical and horizontal components of accelerating to the x direction.
Okay, so when the ball is on this part of the ramp, gravity is still willing to go down, but the normal force has a component to the left. So if F equals ma, then there is going to be a component of acceleration to the left, which the upper road does not experience. So the low road ball starts to go a bit faster in the x, which is what Lakshay told us we had to worry about. And all along, and then it reverses and slows down, but it just gets back, as you argued, to the same velocity as it had before it went down the dip. So at every point in this trajectory on the low road, its speed is a little bit higher than on the high road, in the x. It's true, it also gets some speed in the y, but that's irrelevant. It's the speed in the x. It's always, after it starts falling, a little bit faster on the low road, and it has the same distance in x to travel. So if the speed is higher, the time is shorter.